So this is our, unfortunately, last class together. We'll keep going with the pedal wheels like you guys picked to do last time. I did ask on the Google Classroom site if you guys want to draw something on your own that like to be printed. Let's see if you can share that on the Google Classroom site. If you can share the link, I can see it. If something I can print, I'll ask you for the details. So if you can download the file and submit it as a homework or something, then I will be able to print it out for you. So this is all from the class 2. I just added a few slides on the end. So these are the 4 things we could possibly work on. We have the house, we're working on the pedal wheel. The phone stand is fairly easy. You can do that as an exercise. This is not hard either. So the only difficult part was the do nothing machine is actually the assembly process. How do you set the pins and mate it up with the certain surfaces? That way you can do the simulation. That's the difficult part. If we're going to do it with the pedal wheel thing, it's similar. Okay. It'll get you some idea what's going on. So I figure I'd talk a little bit about 3D printers today. The price of these things has came down a good bit. The most popular one on the market currently, hold on, is the Creality series. The cheapest one is called Under 3. I don't know if you guys are familiar with it or heard about it. So it has a rather large print volume, 220 by 220 by 250. That's, I believe, more or less a 10-inch cube. My measurements, my math could be a little bit off, but just by estimate. So if you catch it at the right time, you can buy it for under $200, basically $170 or $180. If it's something you guys are interested in doing, this is not exactly, expensive anymore. This machine can do PLAs, ABS. ABS plastic might be a little bit more difficult. PLAs are fine. PLA is probably the easiest thing you can print as the FDM machine. Like basically all the in-house 3D printers are. So that's roughly $20 a roll of about 2.2 pounds or 1 kilograms, and that'll last you a very long time. Lots of printouts. So each one of these machines, when you buy it, this one requires subassembly, so you have to put it together yourself, and it comes with a little bit of filament you can test print, and I'll show you something in a little bit. So it give you, each one of these machines, they'll come with some sample files you can print, not the Batman figure, unfortunately. And they all have a little bit of proof figure, small proof figure 3D object that you can use. The version 2 of the Enders is coming out. This has some improvements on it. Adjustable belt tensioner for one. Has a 32-bit board versus 16 or 12. I'm not exactly sure. And the more important part, it has a coated glass bed, so you can do really smooth bottom print, and it's also easier to remove. That's an upgrade. Has the same print volume. Unfortunately, it's going to be about $100 more expensive since it's brand new. A couple years down the road, those become cheaper too. So. Now these are a little bit more expensive. Artillery Sidewinder, that's a $500 machine. This has a larger print volume, 300 by 300 by 400. So far, this is also a single filament machine. And one of the more popular brands on the market is the Prusa USA. They're actually made in USA, I believe. So if you buy as a parts kit, you can build it yourself for $750. If you buy it fully assembled, it's $1,000. This has a fairly small print volume. They have different size machines. This happens to be the smaller one. So it's 180 by 180 by 180. This is the machine that I'm using that the AOE purchased. And as you can see, it's 227 by 148 by 150. So it's 9 inches by 6 by 6. So it's not the smallest. It's certainly not the biggest printing bed. So that's the bed I'm referring to, the blue thing right there. This is a fairly expensive machine. Reason why is because it has 2 extruders. You can print 2 filament at one time, different colors, different type. And this guy can handle PLA, ABS, CAD-G, amongst other filaments. So the maximum extruder temperature is 240 degrees C. So it's fairly versatile in the prints. As you can see, I've been showing you little models that printed throughout the whole class, and they're fairly good. So out of the box, they're fairly good. Not a lot of tuning are required, but of course, everything you can still tune it to your liking. But you know, this is a $900 machine, or just about sub $900 machine. So with that said, I'll post all this on the Google Classroom site. This other thing I kind of like to share, I mentioned this site a few times before. This is called Thingiverse, and it's run by MakerBot. You don't need an account to download stuff, but if you want to comment on things, if you want to put your own designs on it, then you do need an account. So there's a lot of little 3D models available on here. For instance, this guy is a impossible table, right? So it's basically strung together by strings with these 2 pieces. So if you build it right, it can hold actually a good amount of weight. Okay. And you can download the models form that's already in 3D shape. Then you can just load it onto your slicer and send it to your printer. Okay. And of course, it's much more fun when you can design your own stuff and make it a little bit more interesting. For instance, I can show you this. This has been done before by many people. In Thingiverse, I think it was called an impossible box.
Is that Tesla Cybertruck?
Yeah, this is a Cybertruck model. Anyways, it doesn't look like, well, this site gets busy sometimes. Let's just not worry about it. So basically what I did is I actually drew it myself versus downloading off somebody else using Onshape. It's basically a ball in a cube. So you draw a cube, then you hollow it out using some of the operations we learned, and then you draw a ball in the middle of it. And once you print it out,
can you show us the whole thing?
It looks something like that. Can you see it?
Yes.
Should I stop the share? Let me stop the share so you can see better.
Ooh.
Okay. So this is something you can design yourself. It could be different shapes, different things. The ball turns freely inside, as you can see.
That's cool.
So let's get back to our.
What are you doing, Kevin?
Okay, before we get back to our bicycle, our bike pedals, do I have any questions from anyone? Have you guys tried anything else in the past week? Anything you want to show to your class that you've You want to impress some of us?
I just want to tell you something.
Okay.
The max amount number of spikes is 70.
On the wheel before they started crossing each other? Oh, okay, good. So once you start crossing them, they're creating different surfaces, and that changes the diameter of the wheel. So that makes it more complicated. Of course, when you study further into mechanical designs, the gears don't actually look just like the little triangles on top of a wheel. They actually have their own individual shapes, right? I'm not going to get into that. What we're doing is assimilating gears. They're not really gears, okay? So since I don't have any questions from you guys, we can go ahead and get into our next part of the design. So we have this gear, and then we need a shaft that the gear runs on. So instead of drawing it on everything on one parts library or studio, part studio, we can generate different parts off of a different studio, okay? So this guy is 1/2 of an inch in diameter, the borehole. I'm just checking dimensions because it's been a little while. So what do you do is right on the bottom left corner of your screen, there is a plus button. When you hit that, it says create a new part library, part studio.
I knew that was it.
That'll give you a new workspace, okay? So which plane, doesn't really matter that much, but it kind of helps if you know what plane your wheel is on. So that's facing the front panel. We can draw your shaft on the same phase. So how do we do that? We go back to sketch, right? We take your front plane or whatever plane your sprocket is sitting on. Then we do our view normal to sketch. So you guys should be familiar with all that. And then what we do is we draw a little circle. Okay, doesn't really matter what size. And then we use the dimension tool to define the diameter of 0.5 of an inch. Okay, everybody follow at this point? Questions, comments? Go ahead, Will, has something to say. No questions? Everybody's following? Good. So then we extrude it out. Once I extrude the circle out by itself, what am I gonna get? Anybody? Just shout it out. What shape am I gonna get?
Cylinder.
Very good. Give me a number. What size you guys want it?
10.
10 inches? That's a little long.
0.10?
No. Well, think back to your bicycle. How long that shaft usually is.
5
How about
inches.
6 inches? 5? Good. All right, I like 5. Let's do 5. 5 inches. And that's your shaft. Okay? Now we have a wheel here and the shaft. Since they're in separate parts, how do we put it together? Right? On the very bottom of the screen, there's an assembly part, right? You click on that. And the very upper left-hand corner, there's an option called Insert.
Insert?
See where that is? Click on that. Then it gives you a parts list. You can pick what you want to put on your assembly. Right now, we only have 2 parts. We'll have these 2 parts added. We have the gear, and we have the shaft. Okay? So now they're kind of merged together. That's not where we wanted to be. So now we're going to do something called, see all these little options up on top, right next to the insert.
I have a question.
Go ahead.
My shaft and my gears, they, like the shaft is already in the middle.
Well, that's fine. But you still have to define what they are if you want to animate it. That's, yeah.
Okay.
So you can pull them apart. Just click on, say, part 1 or part 2. Then these arrows
Hold it.
shows up.
Hold
then
it, and then you can drag it around.
Yeah, you can move it around. Okay. I need to zoom out a little bit because I want to see the end. So I have these 2 parts. So I want to mate them together. The first one you want to use, because you want these 2 to spin together, right? What you need is a fasten mate, which is the first one on the mating manual. So you click that one, little window shows up. So mate connectors. What do you want to connect it to? So I want to pick the end of this guy to the end, well, the center of the cylinder to the center of our hole. Now they're made it together.
So what tool are we using?
The fasten tool. Okay, so it's fasten mate. On your menu bar, that's pretty much the first thing on the where the menu actually starts.
Okay, then.
Okay.
Then what do you?
I'm having some trouble.
Give me 1 second. This is not actually the right surface. Let's cancel that. Do that again. See, it depends on where you pick. This one is right on the end of the cylinder, right? Click that one. And this one, the one I happened to pick, was on the other side of the circle. I wanted it on this.
Whoa.
I had it on the wrong side of the circle. So I wanted it on the side of the circle that was facing me. So when they mate together, they're flush, like this. But is this how we want it? Not really. We want it in the middle. Well, we don't want fasten 2. We just want fasten 1. So I double click on fasten 1. On the bottom of that little window, there says an offset. Check the offset. It'll let you move in the direction that you wanted to do. So look at the coordinates. X is to your left, to your right rather. Y is to the top. Z is going in out of the paper or out of the screen, right? Depends on which way you spin it. So I want to modify this direction to 2.5 inches to have the shaft sit right in the middle. That's not quite the middle.
That's what happened to me. It's not quite in the
Oh, you
middle.
have to take the thickness of the
Yes, we
I
do.
think it's
How thick
2.5,
was it?
because, yeah.
Let's see. I don't remember. How thick was it? Anybody remember?
0.125 inches.
It was 1/8. So you need to take account of that. So it's 2.5 minus a 16. So it's like 2.494, something like that.
Mine was already in the middle. It's just that it's not perfect.
Well, you got to do some math. If the thickness of the disc is 1/8, and we moved to 2.5, that means we're obviously not at the center, so we need to move it 16 back to the other side. So
I got 2.375.
2.5 minus 0.06. So 2.44-ish. That'll be pretty close. 1/16 is about 60 thousandths. 0.0625. So if you want to go exactly,
I got 2.375.
what is it?
375.
No, it is 0.0625.
Right.
Well, we're adding it, right? Because it's
So, yeah,
supposed to
you're
add
right. 2.4375. 2.4. Well, that'll be, well, any machine can't really do any better than 1,000ths, which is 3 decimal points behind it.
Are we adding it on?
We're subtracting. So from the face of the disk to the end of your shaft should be 2.438 to make it
Minusing half
exactly
of
in the
180,
center.
right? No, we're minusing 130.
Right.
Wait, what now?
We're subtracting 1/16 from 2.5 to make
Mine
it.
was already in the middle, so I don't know what to do.
Then you're fine. Then leave it all.
Isn't there a
Oh.
thing to center it or something?
It's not even. Well, I don't
Well,
think.
that's what I'm doing. So remember the offset, then you change it, whichever axis you wanted to change it with, and work out the math. Then it's even in the middle. Okay.
I also think it's even at the same time.
So now these two pieces are mated together. So to do some more complicated mechanical drawings, you do need to build your parts separately, then add them together. Is Jacob on here?
Can you check if mine's equal?
You can make that decision yourself, okay? Just look at it. If it's obviously different, did you get the offset part? If you got the offset part, then you can change it and slide it around a little.
Mine was already in the middle when I fastened it.
Okay. It's already in the middle of the shaft, or they already in the middle of the sprocket?
The sprocket.
Well, then you need to make sure the shaft is in the
I
middle.
mean the shaft. The shaft.
Then that's good. So let's go back to our parts. So at this point, it's probably nice if you rename what part you're drawing, because you're going to have many, many parts. So right-click on the tab, and go ahead and hit rename. And this one is the sprocket. And part 2 is our shaft. So this way it'll become a little bit less confusing. Of course, you can also change the part 1 of your drawing of the sprocket into something. And then once you started importing stuff in here, it wouldn't show part 1. It'll actually be the name of the part. So part 1 here, we rename it into, right-click and rename into sprocket. Of course, my spelling is wrong. Come on, Google. Oh, close enough. So for this part, we want to name it shaft. Oh, now when you look at the assembly drawing.
I don't see the rename on the side. I don't see the rename thing on the
Okay,
side.
go down to the parts list, right-click on the part. The very first thing is rename. So change the name of your part, so that way in the assembly drawing, it'll be a little better.
First one? I don't get it. Oh wait, so go to this. And then,
I'm not even sharing. Yes, I am.
okay, now I see it.
Okay, good. They have shaft, they have a sprocket, right? So now we need to make the crank arm, right? Since there will be more than one of those, you can see why building the part individually is better, okay? So let's go back and add another part, create another part studio. This is important. right? There are several options. You can create drawing, you can create assembly, a new assembly, depending on what it is. You can even do folders or import parts. Right now, we're just dealing with a new part. Remember when we did the house, we drew every single part on the same part studio. Now we're doing them separately. By doing them separately, you can add these parts in the different assemblies, okay? So let's sketch again versus we can go use the front phase again. Right, this time we're building a crank arm. I'll show you what it is in a minute. So you're going to draw a couple of circles. All right. The first circle, set of circles, is where
Center point circle or corner circle?
there's no corner circle.
I mean the other circle.
It's either a circle or an ellipse.
Ellipse.
No, we're doing a circle. So the center circle has to pass through our shaft. So we make that 1/2 inch. Right. The other side of the concentric circle, we can make it, let's see, a quarter bigger, so it's 0.75, okay, that's 75. So that's 1/8 wall. All right. And then we need another set of circles offset to this set, okay? That's gonna be a little bit smaller. So that's where the pedal will actually go in. So let's just name this a 1/4 inch. 1/4 inch diameter.
What are we doing?
It'll be apparent in a minute.
So 0.5 and then 0.7. Wait. Yeah.
Can you see the dimensions?
Yes.
Just copy the dimensions right now. It'll be apparent in a minute.
I have a question.
Go ahead.
Is this on another part studio?
Yes, this is
Okay.
the new part, right? So what I'm doing now is a crank arm of your bike pedal. Okay, and now I need to actually define the distance between the two. Let's see, how big was our sprocket diameter wise? Is 2.5, 3 inches. So our crank arm needs to be maybe 2 inches at the most. We don't need to be that big. So between the two centers, I want to define the distance between the two centers to be, oh, it's pretty close to 2 inches. Everybody got that? You guys are doing really good. So now let's draw the lines interlinking the two sets of circles. I want to be tangent to this circle and tangent to this circle. All right, escape. I need to draw another line from this circle to this circle.
Mine's a bit close to the edge.
You can move it around, it doesn't matter.
You put it to, I put it to. Yes.
Okay. Then we can use our trimming tool to get rid of stuff we don't need. We don't need this well, actually we do need that. Let's go back. I don't need this.
Wait, so how did we get that curved shape between the two circles? Just lines or something else?
They're just a line. You draw.
Oh, okay, thanks.
Right.
Okay.
One on top, one on bottom. Actually, we don't need to trim anything. Just leave it alone like this. It'll be apparent in a minute why. So our entire drawing is on the front face, right? So now I want to extrude just the center. I'm going to hit extrude, but I don't want to extrude everything. So I'm going to get rid of this. So I'm going to pick and choose what part I want to extrude. I want to extrude this and this only, okay? And that needs to be, let's see, 1/4 of an inch. And I want it to be symmetrical. So it's set on the center of the plane. 1/4 might be too thick. Let's do 1/8. Okay. So we check that. Then we need to do another round of extrusion. But once I hit that, the rest of the drawing disappeared. I don't want that. So I want to go back to sketch 1 and click on the eyeball so I can see the rest of the sketch.
How
Okay?
thick is the
A
extrusion
1/4
again?
of an inch, right?
1/8.
0.125.
Okay.
Yeah.
An H, 125,
0.125.
0.125.
Yes. So I want to do another extrusion. Extrude 2. What I'm going to pick the outer circles. Okay. I want it symmetrical again versus blind. And this time I want 1/4. Okay. This is our crank arm. Of course, I can dress it up in a minute. Everybody following okay?
Yes.
Jenny, questions?
What size is the second extrude?
1/4. Very
Okay.
good.
1/4 is 2.5, right?
Yes, 0.25. Sorry.
0.25. Okay.
Okay, now let's do something a little bit more interesting. So let's go back to our assembly. Let's add the new part we just added.
Assembly. Oops.
So let's put that part, select that part, and put it onto our screen. Just one for now.
I kind of have I am having an issue with mine. It's
Okay.
not okay.
Let me stop, then you can share your screen. Go
Okay.
ahead.
So like I'm trying to extrude this and I already extruded this, but it's not letting me extrude these specifically.
Okay, you need to go to the left-hand side of your screen. It says Sketch 1. Make
Yeah,
Sketch 1 visible.
it is. Oh wait, no, yeah.
There you go. Now you can extrude.
Okay, thanks.
Everybody else okay? You following to this part? Okay. Jacob. And I'm doing this partially.
How big is it again? How big is the little circles?
Which little circles?
The circles that Satan had a problem with?
So the bigger one has to mate with our shaft, which is 1/2 inch in diameter on the inside, which is
Okay.
0.5 inch. The little circle, I'm just picking an arbitrary number because we're making a pedal for it in a minute. That's 1/4 of an inch, which is 0.25 in diameter.
So the big circles are extruded for 1/2 an inch, and wait, no. What's the extrusions for the circles?
0.25.
Excuse
Okay.
me. Excuse me.
Okay.
So, do we have to make another one just facing the other way?
Not yet. Just wait for a minute, okay?
I mean,
You just-
will we?
No, you drew the one part. That's why we're doing the assembly process, okay? So I picked just the one part in here now. We'll do the mating part as well. So go up to
You're not sure?
the fasten mate. Well,
Share, 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 share.
sorry. Okay. Now this part is actually kind of in my way right now, so I'm going to move it out of the way so we can see every single face. And that didn't. Come on. Why aren't you moving? There we go. Move it out of the way so I can see all the mating surfaces. So we're going to do another fasten mate. Click on that. And I'm going to do this part and the end of the shaft. Okay, now these three things are merged together. Okay, so now what can we do? Now the petals needs to be 180 degrees apart, right? So we're going to insert another one of this part of our crank arm. Okay, so where is this one going to go? We're going to do a fasten mate again, right? Make sure you pick the outside mating spot to the end of your shaft. But that is not how we like it. What do? We click on fasten 3. There's a couple options, right? You see the semicircular thing? That'll turn it around for you. And now they're 180 apart. You all get that?
How do you do the flipping thing?
Okay. Fasten 3. You do the same thing with the other ones. You fasten it, right? And then you have this little circle thing. It says reorient secondary axis.
Reorient secondary off.
It's right underneath the offset. So you click on that, that'll turn it around for you. I can actually keep doing it, okay? If I keep clicking it,
It's not.
it turns 90 degrees every time.
It's not turning.
You gotta have your thing highlighted.
Oh.
Did we all get that?
Yeah.
So there's one, let me show you, the next step we're gonna do is show an advantage of why are we doing it like this versus building everything into one part studio. We're drawing individual parts per studio, okay? So now I'll say, I don't really like how this crank arm looks, right? It's way too square, lots of sharp edges. I don't like it. So we can easily go back. Oh, I forgot this one thing. We need to rename it to crank arm. And this part is also called crank arm.
Why? I need to flip the piece around, not turn it.
What's that?
It only turns the piece. It doesn't flip the piece around.
Here, hold on a minute. Go ahead and share yours. Let's see if you can solve it. Okay. Yeah, keep going. You too many times. That's it. That's all you need. Too many. That's all you need.
Really?
Yep.
No, I mean like flip the piece around.
Around to what side? This is how you want it.
See how this has a rhomb? This one doesn't. So it's on the other side.
What do you mean?
It's supposed to be on the other side.
Really?
Yeah. Think back to your bicycle, okay? Oh, I see what you're saying. That's your mating surface thing. Click on that part again. Go back to fasten 3. Then click on that arrow. There
Oh,
you go.
but then
Then you need to use the offset. You offset the thickness. That'll be your z-axis again. Just play with your numbers and let it sit flush. It's probably the thickness of your piece, which is 1/4, .25. Depends on the orient. There it is. Is it flush?
Yep.
Okay, that's it. See, the piece I drew is a symmetrical extrusion,
Share.
so it doesn't matter which side is what. Okay.
Share.
Okay, let me repeat that. The piece I drew, I used symmetrical extrusion, so it has that on both sides. Okay. Say, I don't like how this part looks, so I'm gonna round off some edges, right? So we already did this. If I start to change on this part in this mode, I don't need to come back to redraw everything, right? If I did this assembly in a single drawing or part studio, then I have to redraw every part. Now I don't have to. So let me go ahead and modify the crank arm drawing by adding some little fillets. Okay, so 0.2 might be too much, so let's do 0.1 for now on these edges around them all. Okay, front and back. And I also wanted to have to merge onto this phase. Oh, we didn't like that, so let's ignore that one. Let me redo this. So I want the outside edges on. Okay. I'm gonna round it off a little, like such. And maybe I want to round out these guys too. So more fillet versus 0.2, I want 0.05. So
it doesn't work for me.
well, you have to change your numbers to make it work. Okay?
And which
Not everything's
numbers?
going to be matching. So to swoop these faces together, you need to change the numbers a little more. So I don't know if .05 will work or not. Let's just see if we can merge it in with this guy. Yeah, I didn't like that. Not worry about that then. And now we have a piece that's more rounded. Okay. So when we're done with the fillets, let's go back to our assembly and check out. Look at that. It updated by itself.
When I do the fillet, like it won't like when I go back to the assembly, the mate connectors don't work.
Okay. Show me.
Cause like when I did it, these red things popped up, and when I moused over these, it says mate cannot resolve mate connectors.
Oh, reason being is you fill it on the inside too.
Okay, all right.
Remove the fillet on the inside. You don't need that.
Okay.
Because when you do that, you change the geometry of the circle. So it doesn't know where center is anymore. Doesn't mean the drawing is wrong, but it's just, it didn't like it. it lost its points of reference. That's why it showed up red. But there is something I will give you as a experience speaking, I guess. Now, the shaft piece is pretty tight. In mechanical devices, usually they will cut a little bit of chamfer at the end of the shafting, so make it push through, get the fit started. So we need to do a small chamfer on the ends of our shaft. So let's do 0.05 just for. So what we're going to do is put it on the edge, okay? So we modified our shaft either. So we have a little chamfer here. You guys know the difference between chamfer and fillets, right? Chamfer is a straight cut, and fillet's a curved cut. So now let's go back to our assembly. It has a little chamfer put in there. So every modification you've done to the part, it'll show up as the assembly. Doesn't matter if your part showed up twice or 100 times, it'll always be correct.
Who's sharing right now?
You want to share?
No.
I think I am sharing, aren't I? Computer
Oh
says
yeah,
that.
you got errors though.
I do?
Mhm.
Oh, it doesn't really matter. It's the same problem as before, as the fasten.
I know.
I tried to do what you said, but it still shows up as the error.
Assembly 1. Yeah, mine too looks like. So you can do is
You did what he did.
you can redo. Uncheck this, make connector shaft 2, and repick it.
Oh, I fixed mine. I don't know. Like I clicked back on the fasten.
Yeah.
And I just reselected them and it fixed.
Yep. That's what I'm doing right now. You can reselect it.
Yeah.
Then it's happy. No. I thought it was happy. Which one is fasten 2? Fasten 2 just lost its mind. I need to pull this part out a little bit. Okay, I'm gonna delete it. You can always redo and make it prettier. Shaft, sprocket, this crank arm. I'm gonna pull it out a little and redo the mating. Come on.
Are we doing the stand?
It's not moving.
Dad, can you zoom in closer to your handle?
Like this.
Yeah.
So I'm gonna redo this this fasten.
You have a what's it called? You have
Just have
a chamfer there. I think that's the problem. I think the chamfer is the problem.
I think so too.
I think you attached the you made it the edge, but you chamfered the edge, so the edge didn't exist anymore.
Right. There we go. So which one is fasten 3 doesn't exist? So there's 3 things. What did I remove?
The other side.
I have the shaft maker. Okay, I need to make one more.
The other side. The other side. Oh.
You are correct. I need to fasten. Come on. This guy and this guy. remember what we talked about last class? How do you make things disappear to make it, or temporarily to make it see better? So this works here too. So if you pick your part, right click on it, you can do make transparent. Okay, so you can get hold of it, the parts underneath it better. And then you can uncheck this, it'll show back up. Okay. So I guess unless
No, there's a hide button.
you can hide as well. You can make transparent or you can hide it. Like that.
Transparent, you can still see it.
Well, you kind of want transparent if you want to point a reference, right? If you want to reference your part. So now let's, you guys want a quick break?
What happened?
Sure.
Then we'll come back and draw in the petals, then we'll draw the stand. Then we'll try to make it.
What happened?
Okay, I'm gonna stop the share to answer some questions if you have any. Liam. Are you being silly? Okay, anybody else? Questions? All right, then we'll take a 5-minute recess real quick, and then we'll come back and try to finish this up, okay?
Stretching time.
The one I did. Okay, so now you can see the support, all 4 sides, and the ball sitting in the middle. And then if you want to see how it's done, pull the layer all the way down to 0. See that in the center is the beginning of the ball, right? Then you draw all these support material around it. That's your edge of the cube. And that is step 11. More support, and the cube is taking shape. Step 21, higher and higher. See how that's built up? Each layer by layer. And now I started building the side support material. Layer by layer, it builds it up. And then toward the end,
It finishes.
right, you get your cube. And
There's
it
a
looks
hole
like
in the top. Oh, there we go.
it looks like that.
Not
So
yet. Not yet.
once everything's all said and done, you remove the support material, then the ball rotates free. So you see how the bottom of the ball,
Oh, yes.
let me stop the share so you can see the camera better. The bottom of the ball is not very nice. It's a little jaggedy. That's where it touched the very beginning of the support. Since it's a spherical shape, sometimes the machine has issues interpreting exactly what that should look like. So it has some flaws in that general area. But once it started to build on the top portions are perfect. See? And you can tell where the very top is, where it is right here. You can see can you see the steps finishing? Coming up on it, or the camera kind of fuzzy? Anyways, you get the idea. All right, let's get back to our task at hand. So with 3D printed items, there are things you can do that other machining systems cannot. So I printed these links out. I didn't share yet, right? So these are, I print them out separately, these links. So in theory, you can actually print them together, then they'll still work like that. Because once again, 3D printing builds things up one layer at a time. So long you leave enough room in between the linking pieces.
Can you show them the rings?
The rings? Oh, the rings is not that impressive. It's just circles, little plastic rings. They're not that impressive. So, like I said, I ask you guys to draw something you like. 1.5 inch is the limit per axis, because the tough to get together. This guy took about an hour and a half to print, and this is a 1 inch cube. So imagine printing stuff could be time consuming. I've printed out, we talked about the Ender 3 printer. So I've made a whole bunch of these little puppies. That's your souvenir for the class. Each one of you is going to get one. And I think I made enough of them. Anyways. This,
One thing I'm a little confused on something. Are you going to print out something that we give you, or are you just giving us these bracelets things?
I'm giving these things to you.
Oh.
If you have something that, if it's something you drew up.
Dad.
Got it.
Could you change your camera or something? Oh.
If it's something you drew up and you want me to print for you, I can do that.
Okay.
The limit is
Not for me.
5 inch per axis. So X, Y, Z, it cannot be taller than 1.5 or wider than 1.5.
Right.
Show me what you drew, and if it's something I can print, I'll print it for you. Okay?
Wait, so right now or towards the end of class?
You have a week. You can hand it to me next week, then we'll do it. And it'll take a little while for me to get everybody's printout out.
Okay.
The puppies are ready. There's actually a small story behind these puppies. We talked about the Creality Ender 3 printer. This is the file that comes with the Ender 3. Okay. Now this little puppy is actually called the Ender 3 puppy. What this is a printing capability model that if you can print this puppy out successfully, then that means you tuned your machine incorrectly. Okay, that means there's no if all the lines showed up correctly, there's no missing lines, there's no warping of any kind, you didn't nothing jammed. If it came out correctly like this, that means you tuned your system incorrectly. So this is basically a systems proof model, and I'm giving each of you one of these as sort of a sample, as a not necessarily 100% perfect print, but is 90% plus. So you can use that as a guide if you guys wanted to get into your own printing, right, by your own machines. So this is a 1.5 inch tall model. It's not very big. Okay.
Cool.
I guess.
Cool.
Okay, go ahead.
Huh?
Go ahead.
Wait, you want me to show you the thing I made?
You can.
Okay. I have to warn you, I don't know if it's going to be really good.
Oh,
I mean, it's not perfectly realistic.
Okay.
I just kind of made a crane. The one thing I really have to say is that these three really are just supposed to kind of be my test for whether or not the cables would work when I actually do something with it.
Well, how do you make the cables?
Well, that's
Well,
just
I
an
mean,
idea.
I was just going to, like, when I got it, I was just going to use something around my house because I don't want to 3D print a cable, and we have tons of old string lying around.
Yeah, you cannot print cable.
Yeah, so I didn't want to do that. These are mostly just the guidelines for the cable. I'm going to delete them before I send it to you.
Right. So okay, you did everything in the one part as well. One part studio.
Dad,
Which is okay.
uh,
So one thing you got to pay mind to is look at your wheels right there. Your wheel on the bottom, right? Your shaft and your wheel. You have to have enough clearance.
Yeah, I did a
Okay.
bit of testing, and I'm pretty sure that it's cleared.
Okay. So otherwise, they're not going to go together,
Okay.
right? So, or it will not move. That's what I meant. Very good. You guys took a lot of. Well, hopefully that was fun when you worked on that.
so next week is the last class, right?
No, this is the last class.
Really?
Yes.
What?
Wait, this is the last class?
This is the fourth class, isn't it?
Yes, this is the last class.
To my understanding, AOE is going to do a sort of an advanced class after this.
Ooh.
But, well, that was the discussion we had before. I don't know if it may or may not happen. I think you guys pretty much got everything that I can teach you. As far as
Yeah.
we're doing the assembly process, we'll do the animation at the end of the class. So I think you guys got it pretty good. And I'm not sure how much more we can get into it deeper without you guys doing your own digging, if you can catch my drift. So a lot of this is really on you. I bring you, well, we can bring you the tool, show you the basics. Once you're there, the further exploration, you know, really get good at something, you really need to get into it. You really need to do it on your own. Liam, stop.
Sorry, even forget it.
So, and if there is need, you can still ask me questions on the Google Classroom site, and that'll stay on for a little while if you're running into issues. And like I mentioned in the very first class, these guys has a very extensive help library. A lot
What
of
guys?
the people behind Onshape.
Oh,
There's a lot of videos, a lot of help files, and a lot of tips and tricks. You can really learn a lot just from the help file. So, we'll do what we can to bring you guys into the door. Then further exploration is really, your choice. If it's something you really like, if something you can really want to do.
what door?
Same goes with a 3D printer. If this is something you want to do and you want to pursue that on your own as a hobby, or there's other things you guys are doing, either robotic teams or whatever other teams you guys are with, what other curriculums you guys think 3D printing might come in handy. This is basically a tool to bring you guys into the door, right? So I cannot teach you everything. I don't know everything. So hopefully we have that understanding. Let's keep going, right? So we have the crank arm, we have the shaft, we have the disc. So what's the next thing is we're gonna need to build the pedal. Just like the other model. Okay, sorry. Just like my demonstration model, how I did it is basically a handle versus a foot pedal. If you guys want to draw a foot pedal yourself, you can. That's a good bit more complicated. I'm not going to do that here because it might take up too much time. So let's go ahead and start a new studio, a part studio. You can, just like Windows Excel, you can move these tabs around. So you want to group all the parts together, you can. So we're going to call this one handle. Okay, once again, we need 2 of them on our assembly, but for starters, we don't need that many. So far what we did is basically all extrusion, right? Extrusion, extrusion. This is all extrusion. With the handle, let's do something a little bit more interesting. Let's revolve the handle into a solid, okay? So how we're gonna do that is we're gonna start a sketch, just like before. We're gonna use our front phase again. We're gonna view normal to it. So our workspace is in a perfect 2D dimension. So remember the crank arm, I guess the pedal hole is 1/4 of an inch, right? So when we draw, try to revolve something, we're basically drawing a half of it, then we revolve around into the whole piece. So we need to have a general shape, right? So we're gonna have a little horizontal line out. We're gonna go up. We're gonna go horizontal, and let's just leave that for now. Let's define the sizes. So we want it to fit inside of that 1/4 inch, 0.25 inch hole. So half of it is 1/8, which is 0.125. And the depth of the hole is 1/4 of an inch. If you want to have it flush, and the height of this guy will be 0.25. Okay, and then we need to have a little shoulder. Let's make that, this line here, 1/8 as well, which is 0.125. It's kind of a big shoulder, but that's okay. Then we need a guideline or a construction line from here all the way up to some arbitrary position. So the width of a grown-up hand is roughly 4 inches. Since our sprocket is fairly small, we don't need to make it that big. So it's a model, so we can make it as high as maybe 2 inches. It's arbitrary. So long they look proportional. Well, this one says 2.5. Let's make it 2.5. So long it's more or less proportional, right? So what we can do is draw a couple more construction lines. So from here, I want to line up with that. And I'm going to line up with that, right? So why are these construction lines necessary is I want to draw some circles, okay, or curves. So I want this to be like that. No, the circle doesn't need to be construction anymore. And I'm going to draw, see the curve tool up here, the 3-point arc, right? I'm going to pick that right next to the circle. I'm going to go from here to where the other point merges and make that just some arbitrary number. This says 4.9, which is fine. We can make it into 5 just to round it off. Okay.
Can I have some help?
Go ahead. Hold on a minute. Let me finish. Then when we're done here, we need to close off the area if you want to revolve around this piece. So we need to draw a solid line from here to the edge of the circle, to the center, all the way to the top of the circle. Okay. So we actually don't need the other half of the circle to make it less confusing. So we have this shape here. Okay. Now to make a handle, what do? Is we revolve this entire enclosed area around the center as axis. Okay?
Yeah, can you go back? I kind of missed
Absolutely.
everything up to the circle. I mean,
Absolutely.
sorry, everything after the circle, after
So
making the circle,
remember,
yeah.
when you revolve something, you're drawing a cross section. Okay. So I just went back to there. Let's go back to sketch 1. View normal. So how far do I need to go back?
Basically just, I'm at the circle. I'm at making the circle.
Okay.
But
So
you kind of lost me when you started doing the curves and stuff, so.
okay. So I drew the circle with the
Yep.
point where the 2.5 inch line ended.
Where's the extend? Where's the extend?
All right.
So the radius of the circle is basically the width at the bottom, which is 1/4 of an inch.
Okay.
Okay, so I had this as 1/8 and that as 1/8. Together, that's 0.25 of an inch. So the shape of it is more or less arbitrary. You can make it look like that, but it can certainly be a
Oh,
different
wait, go back
shape.
a little while. Sorry, I was just making a line. Hold on.
Okay.
Sorry. I'm so sorry. It's a little thing.
So,
So, like,
basically,
how big is
this
the circle?
This is the key geometry here, right?
Yeah.
This place right here.
How big is the circle though?
Mine is 1/4 of an inch in
Okay,
radius.
0.24. Then I don't understand how did you get like that curve?
Okay. So this is a 3-point curve. Let me
Oh, I see.
delete this so I can do it again. So right now, it's for a 3-point curve. It's basically the first point, second point, then you get to manipulate the center. That's what a 3-point curve means. So what I did is I started on basically the joint part of the circle, the end part of the circle. That's my first point. And the second point is where the step ended. Then I just messed around with the shape of it. Okay, you can make it a tangent. You don't want to go
What
too
tool
far.
is that?
It's the tool right next to the circle tool.
The connect tick.
It says 3-point.
What's the
curve.
top tool? What's the top part? What's the
Top
top?
part is the circle. I drew
Really?
a circle, and then I just cut off half of it with the trim tool.
Oh.
So then you want to make it a little prettier. You can, since it's a blue line, you want it to be a black line, so you can define it to whatever the closest full number or whatever number you like. This is all arbitrary. So now you have it enclosed.
Okay,
shape,
thanks. That was really confusing for me.
right? Then you can revolve around. And the other thing you can do is, like I said, this is just arbitrary, whatever you think it looks good. And the other thing you can do is you don't necessarily have to have this. You could easily just draw a line from this point up to maybe there. It's arbitrary. And if you revolve around that, it'll give you a different shape. Of course, the revolving axis is your center line there. So you can make a handle like that, or you can use the 3-point curve arc rather and make a more rounded shape. Of course, once you get here, you can actually use your fillet tool to
Can you wait? Can you go back a few?
look like something else. Okay, how far?
Like before they extrude some parts?
Right
a little
here?
bit more. A little bit more.
This
How do you do
step,
the round thing?
this round thing. This
Yeah.
is circle.
Not that. The other round thing.
What other round thing? There's only a round thing, only one.
He means the 3-point circle.
Oh, the arc?
Yeah.
Okay, let me delete this. So right now you have a point here.
Mhm.
You have a point here. right?
Yeah.
The tool right next to the circle is called straight point arc. You click on that, that's how you draw a curve. So I pick the top point here, and I pick the bottom point here. Then I just manipulate the third point into something like this. Okay. To make it not blue, all I need to do is define the radius that it was already there. So it's 5.23 now. You can
Can you define the
make into a whole number into 5.25.
So you can define the size? So define the size into what?
Into whatever. If you use the dimension tool, you can just define to close to whatever you already drew. Because this is just a shape. It doesn't really matter what it looks like. So the other thing you can do is make it tangent to the circle. Right now it's not. To do that, remember that all these tools up here, okay?
I'm
and
still
click on the line, and click tangent, and click on the circle. You can ship out, it won't like it now. Because we already defined the radius. So if I don't define the radius, go back one, go back two, go back one more, go back one more. Okay, so it's still blue, then you can still move it. So you can make it tangent to the circle. Make the curve tangent to the circle. Still doesn't like it.
What?
Yeah, forget it. It doesn't matter.
My circle just disappeared when I tangented.
Forget it. Go back. You don't need to do that. I guess that this is all arbitrary. It doesn't have to be specifically anything.
What size is yours?
You can make this a little bit shorter. And actually a little bit bigger.
That's too small.
Make it mathematical. I'm still gonna miss a little part. That's okay. It's that it's a handle. It's more about looks than what it really is. So instead of extruding, we're gonna revolve this part. So we involve the semicircle up on top and the bottom piece. Revolve around the center axis.
Revolve.
A handle.
Okay.
I remember was that we talked about.
Wait. Do I make the
You can
Do
make
I
it
make
look like
the
whatever.
construction lines real lines?
You need a line in the middle to make it an enclosed area, otherwise it won't revolve. So we need to put a little chamfer down here to make it fit better.
Wait.
0.05 in chamfer. Okay.
Can you wait?
Everybody okay with this far? Following okay?
Yeah, I'm fine.
Jenny, no problems?
And then revolve. What? How do you make the revolve axis? What's the revolve axis?
Your center line.
Uh.
So if I go back to my sketch, my revolve axis is at this center here.
I can't see the construction line because I put a
Doesn't
real
matter.
line over it.
So long as that line is either real or not, it doesn't matter.
It just makes a ring.
Well, because we revolve the surface. You need to revolve a solid. Okay, show me your screen. Make it a little
Wait,
easier.
never mind. I'm doing it. Never mind, it works now.
Okay, very good. So make sure you do that little chamfer thing down there. Of course, when we made our mating surfaces or mating cylinders, these are all exactly
How
the
do you make
same
the
size as the holes, right? In real life, it doesn't work that way. Either the hole has to be a little bit bigger, or the
Why doesn't it work
mating
for me?
surface
The transfer.
change the size.
Can
The
you share
default-
your screen?
Yeah, please.
No, I mean like, can you?
Oh, sorry. So in real life, when you make parts, this is what I'm talking about, right? This little shafting stubby end meant to fit into a hole, right? So our hole is 0.25 an inch. And you made this part 0.25 an inch. So these two are exactly the same size. In real life, they will never fit together. Either the hole needs to be a little bit bigger or this stubby piece needs to be a little bit smaller, just to keep in mind, okay? Since we're doing it just for simulation, it doesn't matter.
How do you change the size?
Of how do I change size of what?
Base.
The base?
Mm-hmm.
Go back to your sketch,
Okay.
okay? This is what defines your diameter of the top.
Oh.
And when you change that, you change the solid piece of size. So with that there, we can go ahead and add this piece into our assembly, right? Same idea. We insert our handle, just the one for now, put it somewhere out of the way. Then we pick a fastening, not revolving, fasten mate, right? That'll go basically this point on the very bottom end of the piece. That'll go into here, the very end here. We can zoom in a little, pick our spot. Okay, now that's made it together. This seems like it went a little deep. Let's
It doesn't work.
let's redo this. This doesn't look right. Let me zoom this guy out, move this out of the way a little. So unless the shafting is a little long, so we're going to use the fastening mate and the end it here until, oh, come on, into here. That's a little better. Okay, now we can show our little fillet over there. Okay. Then let's pick another part. Handle again. Leave it over here somewhere. We'll do the same thing. We need to do a fastening mate. The end here into here. Now notice this is backwards. How do we switch
It
it?
just made mine bigger.
Go click on that arrow to flip it around. Okay. Now we're almost done. Okay, what happened, Liam?
Can I share my screen?
Yeah. What was your question?
Can you look at this?
Yeah.
It's 1 through 5, right?
Yep.
Is it supposed to be like that?
Yep.
Why doesn't it work then?
Because your other number should be 0.25. The height of it should be 0.25. That one.
Oh.
Okay. Now put it in your assembly.
Don't I need to transfer? It
Change
still
this
doesn't
to-
work.
Yeah, because it's too big. Change the 0.2 to 0.05.
Oh, thanks.
Okay. So now let's draw the base. So I think this guy is about 2.5 inches. This guy's about 3. So it's really small, but anyways. So we need to know the size of the, how big the stand needs to be.
You're not sharing.
Sorry. So we need to build a stand so this whole thing can sit on. Then we can make it go round and round. Okay. So now we can go back to adding another part studio. Okay. This is fairly easy. We'll just draw another extrusion. So we're going to draw on the front face again. We've been drawing a lot on the front face today. So one circle. Remember our shaft is about 1/2 of an inch. We'll define that, which is 0.5. Then we need a support circle as part of the body. So let's make that 1 inch in diameter. Okay. And then we will draw a line going out this way. Actually, let's draw a construction line in the middle so we can define the height of it. All right, so make sure everything's clear. We will make this line 2.5. That should be long enough. So that should be the height of our stand. Then we need to draw a line from the outside. End it up somewhere here and here, right? So once we have that, we can mirror these two lines over to enclose our area. So we choose mirroring, axis, U, and U. The dimension really doesn't really matter unless you care. So we're just building a basic shape. So we're going to extrude out this shape. And I don't remember how long our shaft was. Anyways, let's make me think. Assembly. So there was 1/8 of an inch. If we have a 2-inch gap in the middle, that's more than enough. So yeah, 2.5. So the extrusion here is going to make it 2.5. Okay. So this is obviously not much of a stand because we're still missing something, right? There's no hollow in the middle. So where's our stuff going to sit? So easy. We're going to start a new sketch on the right plane, do normal to it. I'm going to draw a line. Let's see. We're just going to, well, let me change something real quick, make things a little easier. Instead of a blind extrude, let's make a symmetrical extrude. Then we can just draw a rectangle on our plane. From here to here. I'm going to measure the distance here to 0.25. Oh, it's a little big. And make it smaller.
It's 30.
You can just drag it around since it's still blue. 0.25 here. Liam, you need to mute yourself. Okay, 0.25 all the way around. Then we're going to extrude our little rectangle here. The top doesn't really matter.
Can you go back to the sketch view? Because I don't, for like the 0.25s, how do you specifically get those ones?
Okay, view normal to the right plane. Well, in my case, it's the right plane. Then you can just use your measuring tool, dimension tool, pick out the edge of your model and go to the line you just drew. Right, and you pick those, then you can tell it how far apart that is. And if the line changes a little bit, say if we drop outside of the defined parameter, that's fine. You gotta do is drag it back in. Like this blue line right here, since it's still blue, you can actually change it like this. Once it's black, you can't change it anymore. But when it's blue, you still can. Okay?
Okay.
And then we'll just extrude, remove, and we can do a symmetrical extrude again, and make it like 3 inches or something. Clear both sides. Now we have a shell. Okay. So far, so good?
Yeah.
Can you wait? I'm really behind.
Okay. I'll give you a couple minutes.
Can I have some help?
Okay. Go ahead, share real quick. I think we're running a little bit ahead of time today, so that's good. We got maybe 20 minutes left. So if you have questions, now's the time. Okay, use the fastening. Yep. And pick your mounting surface. Yep. That. And okay, hold on to the control button and move your stuff around to where you can actually see the other side. So you picked the wrong spot on the crank arm. It needs to pick the other side, not this side. That doesn't matter. Rotate to the point where you can see it. Nope, wrong side. You want it to be flush to the other side.
Really? You mean this side?
Yes.
Oh.
No.
What do you mean?
You have a curved side and then you have a flat side. You want the peg to fit on the inside.
The inside? This?
Yes. Okay, rotate your model to the point where you can see that clearly. Right there,
What?
right there. Like that. And rotate it around. Click on the arrow. That's it.
Okay.
And do the same to the other one. Okay. Once the stand is drawn, you can go ahead and move that, import that into our
I'm really confused. I don't know how you got there. I'm so confused.
Okay, what are you confused with?
I got the rectangle. I did it on a different axis, so, but I didn't really got all the dimensions. I barely got anything, pretty much.
Okay, you want to share real quick?
Share, sure.
So when I drew everything, I tend to use the planes as a tool or the origins as a tool. So when I draw around these physical positions, so when I do my extrusion and everything, I go around them. So I changed the extrusion parameter on this one into a symmetrical extrusion.
So no, I don't know how, like.
You can do it this way too, it makes no difference. So now I'll use the right, nope.
What?
Did you pick 2 lines?
Yes.
Okay, wait, what'd you just do?
So then this one and this one,
Yep.
right?
Yep, you're right.
0.25, right?
Yep.
And this one and this one, 0.25.
How do you make it?
And then
Hold on.
there's another dimension, right?
Yep, that one to the bottom.
This one and this one?
Yep.
Well, how much is this?
0.25. So
There's one that's like up here, right?
You don't need anything up there because you're
okay.
removing all that. Your
Okay.
socket's going to fit in there.
So what next?
What I did is a symmetric extrusion, make it nice and wide. It just
Okay,
removes all that material. Go ahead.
Symmetric.
Do removal first. Solid remove.
Then
And then right next to the arrow, there's a drop point. Symmetric. And make it 3 inches.
okay.
Or bigger for that matter. You can go even bigger. Yep. This way.
Thank you. So I was so confused. Thanks.
No problem. Okay. Somebody else has something to say?
Since I was really behind, can you show me how to make it?
I'll do that after class. Okay.
Okay.
So let me show you guys how to do the animation part. At least then you have all the tools to work on your own projects. So let's go back to the assembly. We'll insert our new.
Share screen.
Oh, sorry. We insert our stand into our assembly, okay? Same process as before, like that. So only difference is versus a fastening tool, we're gonna use
I
a,
can't put my stand in because I didn't make it.
and just watch. So
Okay.
versus a fastening mate, we wanna use a revolve, okay?
Okay.
This one, the Revolute mate. Okay, the one right next to the fastening mate, the Revolute mate. So we want to mate at the same position as well, but we're going to use an offset to change it in a minute. So we want which point? We want this point, and we want the very outside point. Okay, so obviously that doesn't look very good. Then we need to do offset onto, oh, that's the wrong one. Revolute 1, offset. Okay, that's a z-axis. I want to move it to, well, let's go to 2 inches for now. Well, that's the wrong way, so -2. Too much. -1. That's about right. Once again, this is more or less arbitrary. It's not center, but it's just to prove a point, okay? And look at the handle, look at the crank arm, everything seems clear if you put the stand, actually bolt the stand into place. So one thing we need to do is find our stand and right click on that part, right on the, toward the bottom of the first block in the menu, it says fix. So I want this guy to be fixed. Okay, so you have a different symbol show up there. Now, all the other parts are fastened together, meaning they're not supposed to move about.
How many minutes of class do we have left?
10 minutes or so. Okay, so this is the fun part. So right now, you have
That
this.
thing's starting to lag.
So you go right click on Revolute. There is an option on the bottom that shows animate.
This is where the fun begins.
Yeah, click on that. Let's see if it works. So it starts 0 degree, it revolves around z-axis, and let's see if it works.
It does work, apparently.
Yeah. So this will do it one time.
I have a quick question.
Okay, now let me just finish this point.
Okay.
If you hit reciprocating playback, this will run continuously. Okay, it'll go forward this much, 1 revolution, and it go backwards back. Then it'll just keep going. Okay, let me stop that. Go ahead, what was your question?
For mine, when I hit the animate, the gear assembly stays the same and the stand moves around.
Well, because you need to fix the stand.
Oh, how do I do that?
Okay. See this right here? That's my part in the stand. If I close this, if I highlight this, that's my stand. Find the part that is my stand, your stand.
Yeah.
Right click on that. Well, since I already fixed it, I have, it's in the same spot, right? See all
Yeah,
these
so-
lines separating? It's very on the first group.
Do I just hit fix?
Yep.
Okay.
Once you fix it, you have a symbol there. That means that guy's attached to concrete.
Yeah, I see it.
So it doesn't move anymore. So next time you try to animate it, it'll go the right way.
Okay.
Now, can you help me make the base?
I will. Or you can try to make it on your own, okay? Liam, you know enough about this stuff to make one on your own. If you're running into problems, I'll talk to you when the class is over, okay? We only have a few minutes left. Okay, now I'm gonna open it up for questions. If you wanna show everybody what you had, you can. If you have questions about this particular project, you can ask me about that. And you notice this little arrow here? You can actually click on it to make it like change direction, I think. Oh, because I unselected it.
That just resets it.
So, yeah, you're right. I think I was able to get it going before, but today it's not letting me. So you can click on it and change rotation in theory. Or is it up here? Maybe it's up here.
Watching it when it's not lagging is just so satisfying.
Yep.
So when you, this is part of why 3D drawings is really useful. So with all these parts, if you're doing it for real, you can check tolerances, okay, make sure everything fits. And in real life, this stand will need to have some bearings on the inside of that to fit over that shaft. And it can't just possibly be a physical piece. It will turn, but it won't turn very well. Because remember what I was saying, the hole is 1/2 inch, the shaft is 1/2 inch. In real life, that's called a press fit. And there is no way that shaft will turn with a press fit part, okay? So you have to have building clearances. And we're done with this. Let me show you the do nothing machine that I made actually works. I can show you what I meant by clearances, okay? Hopefully I can find it. There we go. So this is the assembly of the do nothing machine, right? I'm gonna put it into the animation mode.
Why is it called Do Nothing Machine?
Because it doesn't do anything.
I mean, not anything significant.
Yeah, it doesn't
For
do
the
any
most
work.
part, that's it.
That's exactly it.
It's actually rotating it when you animate it.
Yeah, it doesn't do any work.
Yeah.
What's actually rotating when you animate it?
The pins. The only Revolut mating is these 2 pins,
So pins are rotating?
right? And these guys, the
So that means the pins are fixed, right?
That means they rotate around the pins.
Oh no, the machine base is fixed.
The machine base is fixed, yes. And these are slider mates, the trapezoidal shapes. And they sit on this.
Looks like my ingots.
Right.
Just
So
with no curve
what I
size.
meant by clearance is you can actually see when I line it up correctly,
With little gaps.
You can select front on the cube on the top
it's
right.
at the air gap right there. You can see that? So if there are no air gap, if this size and this dimension are exactly the same, it'll never slide, right? It has to have a gap. You have to have gap on the side, you have to gap on the bottom. If there's no gap, it will never
Manually add the clearance, or is it automatically?
you have to manually add it.
Okay. So what's your point?
There are tools here as a table, named positions, tolerance displays. So when you design something for the machinist or whomever to make it, you have to define the tolerances of the pieces, right? The designer or the engineer has to call out, this piece is 1/2 inch within 3 thousandths. That means plus minus 0.003 of an inch. Okay, you have to define the tolerance. So the clearance has to be built in by the design. The machinist, whomever that's building the piece for you, you cannot expect them to know what to do because you are the designer, not them. Okay. So this is just something you need to know. So what other surfaces on here you think has a clearance, right? We have clearances in the tracks. Since this is a rotating member, you need to have clearances on the hole where this bar is, right? So otherwise it wouldn't be cranking very well.
It always looks like it's gonna slide off, but the other trapezoid always prevents it.
The trick is the length of the two holes, the bar. The length of this control bar is actually the optimal definition.
Pretty impressive.
Yeah. So
Impressive indeed.
the tutorial on how to draw this is actually on YouTube. It's just called the Do Nothing Machine in Onshape. If you want to follow that gentleman, he might be going a little bit faster than how I'm doing.
How
it.
many minutes left?
Then you will
3.
Okay, thank you.
If you like to go, feel free. I mean, I'm not going to stop you if you're bored.
I
Okay?
have a question that kind of pertains to all of us if we share our things.
Okay.
So what's your Onshape email, and when we share it, do we have to check any specific boxes in order for you to be able to 3D print
Okay.
it?
Let me show you this. Okay. Whatever file you want to see, I already did that for the 2 projects we did in class. Okay. So on your file, you highlight it, and you can right-click it, and obviously you don't want to make it public, but you can choose a share option. You can share it by a specific person's name, or you can do it by link. Okay. Link sharing. So you just highlight this link, copy it to clipboard, and paste this link into our Google Classroom site.
Another way.
Then whomever else has the link can actually see it. All right. Anyone with the link can view it.
There's another way to copy the link.
So yeah, there are other ways. There's that.
Like going to the top and copying, pasting that. The whatever you searched up.
So you can do that, or you can put in this person's specific email address if you have it. Then you can pick them. You can do edit, or you can just view. Okay. And let me put my email address in the slide. Then I'll put the slide on Google Classroom when you need it. I'm going to put it here. Okay, this is my Onshape email address. So this is already saved. When I put this document onto Google Classroom, you guys will see that, okay?
Okay.
You can share the design with me. Or you can do the link sharing, like I think Jacob already did that a few times. To go to Google Classroom. This is our 3D drafting class. See, I did share the 2 files here that what we're working on. And this is something Jacob drew up, the hoverboard, and he built a metal detector, right? So we can take a look at that real quick. He's already shared this with you guys. That's very impressive. So there is one problem though. So he only has one part, right? To actually be able to build this machine, you need to have multiple parts. So that's why we went through the assembly process today. So when you define different parts to attach together, that's how you can print or how you can actually make this device. And if you draw everything together like this, and it will not be very successful when you try to build it. So the one thing we didn't really do in our class is the drawing process. And you can explore that a little bit on your own. since we're doing this for 3D printing purposes anyways, you really don't need to know how drawing works. Unless you work in a team environment, you have to share drawing details with your teammates or colleagues or whomever it is you're doing stuff for. So this is sufficient enough for now. Okay, any more questions?
Can
All
you
right.
help me with the base later?
I will. Did you all have fun?
Yeah,
Yeah,
it was
it
fun.
was
Yeah.
interesting, right?
Lots of fun.
It was really fun.
It's hard work, especially
like it.
starting doing more and more of it.
I like it very much.
Hopefully is rewarding enough.
Thank you
And,
so much. I
uh,
think you guys, we can see you guys liked it very much.
Uh-huh.
Thank to Mr. Wang for giving us this wonderful class. Okay, let's give
Thank you.
clap hands on your participant list to thank you. To say thank you to our wonderful teacher.
Thank you. Thank
Thank
you.
you.
Yeah.
all right.
And you know, in high school, there will be a class called tech class. Thank you, Thomas, for putting the clapping sign on the
Thank
participant
you.
list.
Thank you guys very much.
Yeah, this will help you eventually. And you can do a lot of stuff with this, you know,
Right.
skills you have learned from this class. Yeah.
So 3D drawings and 3D printing is the way of the future. This basically was the new environment, was all these new software available that really take a lot of draftsmen out of the job, because it's much simpler than how they used to be. So yeah, explore it. I'm sure it'll help you in your future academic career. And I'm not sure is it still the curriculum or not. When I was going through college,
Can I leave now?
Yes, you may. Yes,
You
you
are
may.
free to leave. Yeah. Okay. Thank you.
Class is over. We're just chatting. If you want to
Yeah.
stay, you may. If you want to go, you may.
Goodbye.
Goodbye.
Bye.
Thank you. Bye.
Thank you. Bye bye.